Now in this session, we're going to discuss about handling the outliers. This has already been discussed in the second unit, but let us have a glance of handling this outlier for one more time. Right now, what exactly is an outlier? Outlier is the value which is just at the boundaries of the entire data set from the midpoint. Midpoint usually be a mean. From the mean, what exactly is an outlier? Most of the data points will be clustered around the mean, but some data points will be far away from the mean. For example, there is an age in which mean is, let us say, 30 to 35 is the mean. What will be the outlier? For example, again, take the same old example of Flipkart dataset. In the Flipkart dataset, there are some customer database. In the customer database, ages are ranging from 5 to 70 to 75. But here 5 or 70 or 75 will contribute a very little to the model, because you don't expect the people who actually are from the ages 5 or 70 or 75 to purchase something from the Flipkart. These will become the outliers. We should be able to handle the outliers efficiently. Having said that, we also need to understand, we also need to have an eye on the fact that in some models, outliers also contribute significantly to the model. So we should not remove the outliers, or we don't need to handle the outliers in those models. If you have to handle the outliers even in those models, those should be appropriately handled, not simply by removing. Okay, so we'll understand how exactly we're going to do it. Yeah. Now, first of all, in order to handle the outliers, it is very important to understand, it is very important to identify the outliers. How to identify the outliers? There are several ways. First one is box plots, scatter plots, and histograms. By using this, you know what is a box plot, scatter plot, and histogram, by using which we'll be able to handle, identify the outliers. Z-score. What is Z-score? I'll show you in some time. We'll be also, see, Z-score is a statistical method by using which you'll be able to analyze an outlier. I'll directly show you what is a Z-score here. Yeah. What is a Z-score? How will you be able to calculate a Z-score? Z is equal to a data point minus median divided by standard deviation. You know what is the mean? What is mu? Mu is the variance, right? The mean divided by standard deviation. Mu is the mean of the data set. Okay, this is the data point minus mean divided by standard deviation, bigger pardon. This is how you're going to calculate the Z-score. Okay, now what exactly is Z-score? Anyhow, where Z is the Z-score, X is the data point, mu is the mean of the data set, sigma standard deviation. Now, if there is a Z-score of 0, after calculating this, if you get a Z-score of 0, the value exactly is at the midpoint. The value is exactly at the mean. If a positive Z-score indicates the value is above the mean, positive Z-score meaning the value is above the mean. Negative Z-score meaning the value is below the mean. Rule of thumb for the outliers. How this Z-score is going to participate towards the data set identifying the outliers. A greater than 3 or less than 3 are typically considered to be the outliers. If the Z-score is plus or minus 3 or beyond, what does it mean? It actually is an outlier. This data point is considered to be an outlier. Adjust the threshold based on the data set and domain knowledge. Now, when you get a Z-score which is greater than or equal to 3, we should be able to handle this. There are some ways to handle. Depends on how this Z-score, how this outlier is contributing. If it is not contributing, you can remove it. If it is contributing a little, you just can replace it. If it is contributing more, what you can do is you can appropriately handle this. For this, you need to have a domain knowledge. For example, a doctor's data set, what do you call the hemoglobin percentile in your blood. Here Z-score contributes. You need to retain, but only the person with a specific knowledge can retain it or can implement techniques to handle that. So all the outliers may not be all the outliers may not be removed. In some models, they will be retained. In some models, they can be handled. Okay, all the, what do you call, the outliers need not be the culprits here. Yeah. Another thing is, first one is identify the outliers, visualize the outliers, statistical outliers. I mean, in identifying, we use statistical methods such as z-score or interquartile range. You know what is an interquartile range? We discussed about it. Domain knowledge. You don't require any statistical methods if you have some domain knowledge. For example, some doctor's data set. Doctor can identify what exactly is an outlier. The next thing is domain, as I already told you, domain knowledge. And next thing is from where the outliers may arise. Data entry errors. From the data entry onwards, there is an outlier called 137. In the age column, accidentally, the guy who enters the data entered is as 137. 137, there is nothing as such 137. There is no age such as 0, right? So there may be some entry errors, measurement errors. During the measures, there may be some significant errors. When you measure, let us say you're taking the value from a measurement instrument. Okay, so let us say temperature must be in and around 20 degrees to 120 degrees Fahrenheit. And if it is anything less than this, obviously Hyderabad weather would not fall under 20 degrees or 120 degrees Fahrenheit, right? So if it is something more than that, that means that we are at poles. We are not at poles actually. So there may be some measurement errors, sampling issues. In data sampling, there may be issues which causes you to arise these outliers. Natural variability, valid data. Obviously, this is a valid data. For example, in the Flipkart data set, there is some contribution from customers of 5 years of age, 75 years of age. But they don't contribute much. They're the actual values, but they contribute a very little to the data set. There are the possible legal values here. Okay. How to handle the outliers? Simply ignore the outliers. Don't handle them. Keep them. Have them in your data set, but you don't handle them because they may contribute, they may not contribute. You don't mind them. This is the first one. Second thing is remove the outliers. What is it with this removing outlier? You should completely be able to eliminate the outliers. Okay, what after it is identified. Use the method only outliers or errors are relevant to the analysis. If outliers are caused by the errors or it just is completely irrelevant, you can ignore and remove it. Removing rows and extreme values. Transform the data. How you'll be able to transform, meaning outliers can be transformed. The first one is logarithmic transformation. You cannot have the outlier values the way it is. Rather, you just want to change it to some meaningful value, such as logarithmic transformation. You also can square root it, apply the mathematical transformation to reduce the impact of the outliers. Okay, to reduce the impact, we have three techniques: logarithmic transformation, square root transformation, box cos transformation. I'm not getting into more into the details because this is irrelevant. Cap or clip the outliers. Replace the extreme values with a defined threshold. Now there is a threshold. For an example, 15 is lower boundary, 55 is the upper boundary. Anything falls below this 15 or beyond 55 will be replaced with this 15 and 55. This is a threshold value. The total outliers will be replaced only by these threshold values. Use some robust statistical techniques. Next thing is use some robust statistical techniques. What we do is employ models metrics are less and sensitive to the outliers. So we'll use median or instead of mean. Rather than going for the mean, we'll go for the median. This median, see, when you take the mean, there is an outlier. But when you take a median, outlier is less sensitive to, see, this median is less sensitive to the outlier. I hope you got the point. Now this is a data set. In this data, this is a mean. From the mean, when you calculate, there will be outliers. The data points which are falling here will be the outliers. But when you take a median is very less sensitive to the outliers because median is not mean. Okay, median is the most repeated value, right? Yeah. And mean absolute deviation instead of standard deviation. Standard deviation, when you take a standard deviation and you calculate a standard deviation of a data set, obviously it's prone to the outliers. What is the standard deviation? Average of sum of all the squared variance, right? It's the standard deviation. But When you talk about variance, variance is the difference in between the data points from the mean. But that is going to be the biggest problem with respect to the outlier. But when you take mean absolute deviation, this mean absolute deviation, as you already knew, it is less prone to the outliers. Impute the outliers. Next thing is imputing the outliers. We should imputing these outliers will be replaced by some other values such as mean, median, or the nearest neighbors. Use the algorithmic resistance to the outliers. What are those? See, in some models, outliers is not a biggest problem. Some machine learning models, such as decision trees, random forest, and gradient boosting algorithms, for this, these are not sensitive to the outliers at all. For these models, you just can keep the outliers the way those are present in the data set, because these are resistant, these models. You want to, in order to design a model, for that you just need to have some machine learning algorithm, in which if you, in the data set that you have collected, if there are more outliers, better to see if your model can be built by using these machine learning algorithms, because these machine learning algorithms are less sensitive to the outliers, are not sensitive, these are resistant to the outliers. If you can use them, those can handle pretty effectively the outliers. Okay, so this is how you will be able to deal with the outliers. Thank you.